Okay, so here we go. This is what you need to know. That you have a test when?
Wednesday and Thursday.
Wednesday and Thursday. Okay, what's it over? What sections?
Absolute value.
1.7 to 2.3.
1.7 through 2.3. We're going to almost get finished with 2.3. Gunner, sit. No. We're almost gonna get finished with 2.3 today. Okay, we'll like one thing. I'll finish it tomorrow. Take me 10 minutes. Okay, and then you'll be off and running, and you can study for your test. I'm gonna have some very strict rules. We're not gonna be talking and all that kind of mess. Okay, your worksheets are due Wednesday. Tomorrow, your optional project is due. Did you hear me? Your optional project is due. If you don't give it to me tomorrow, I don't care about your excuse. Does everybody understand? Okay? It's tomorrow or it's never. All right? Don't come and tell me, oh, Miss Davis, I did it. I worked 10 hours on it and I left it at home on my bed. I'm so sorry. Y'all have until 8th period to get it here. Okay? You better find a friend. Phone a friend. I hope they have a car. All right? So, it is what it is. All right. So first of all, a little review. Linear functions. Okay? If it's a linear function and I graph it, what's it going to look like?
A line.
Very good. Okay? Tell me what can it have? If I look at the equation, what can be in my equation? What should be in my equation?
X.
An x.
And a Y.
To what power? Yeah, it's probably going to have a y, an x and a y, but it doesn't really have to have a y. It could just have an x, right? Okay. So, what can it not have?
Absolute value.
An x to the second power. An absolute value. You can't have an x inside the absolute value. That's not a linear function.
And then the one
A
over
log.
the X.
What?
The one over the X.
A 1 over the x. You can't have, y'all listen, if you have an x in the denominator, that is not linear. Did you hear me? If you have an x in the denominator, it is not linear. Even if you think you're doing some fancy math on it, and you end up, and you don't have an x in the denominator. If you started off with an x in the denominator, it is not linear. Has everybody got it?
Yes.
Okay, anything else? What's the parent function? What's the parent function of a line?
Is that Y?
Okay, so I'm going to use function notation. F of x is equal to x, y equals x. You agree? What's that look like on a graph? Okay, tell me some points that'll be on this graph.
3.
1 what?
1, 1.
1, 1, because x is equal to y. So 1, 1. Tell me another one.
2,
2,
2.
2. Tell me another one. 3, 3.
4, 4.
4, 4. What about 0, 0? What about negative 3 what?
Negative 3.
Okay. So does everybody agree that he looks kind of like this? Are you with me?
Yes.
Okay. So let's talk about the domain of this function. I'm going to write it in interval notation. Okay? I'm going to write it in interval notation. Now listen, when I'm talking about the domain, I'm talking about the x's. So what I'm going to do is I'm going to read my graph from left to right. It's very natural because that's the way we read here. Okay? So remember that this arrow not only keeps going down, but it also goes
Up.
left. Yeah, he goes down and to the left though. Do you see what I'm saying? And he goes up and to the right. So I'm reading my graph from left to right. Left to right. So on the x-axis, this function goes all the way to what?
Negative.
Yeah, negative infinity because he keeps going down and to the left. So he starts out here at negative infinity. And then he goes up and to the right all the way to where on the right?
Positive infinity.
Positive infinity. Very good. My range. The range, it's best to read the range from the bottom of the y-axis to the top because the way you write interval notation, remember, is the smallest first. So start from the bottom. This arrow means he goes down to what?
Negative infinity.
Negative infinity. All the way to
Positive.
positive infinity. Very good. Everybody okay? Okay, so let's do example 1. We are going to graph the equation. Graph the equation. Now, most of you people like for your equation to look like this. Y is equal to mx plus b. Okay? So this is called slope-intercept form. Sometimes when I ask for the slope formula, this is what y'all give me. This is not a slope formula, okay? But it is slope-intercept form. And it tells you what the slope is, right? So m is equal to, that's the number in front of and multiplied by x. That is my slope. And my y-intercept is what?
X plus B.
What?
X plus B.
B.
B?
Oh.
Yeah, he's B. And whatever sign goes with that number, okay? So that's my y-intercept. So what we're going to do is every time I have to graph something, we're going to write the slope and the y-intercept. Did I model that for you on your worksheet? Yes, if you've looked at it, then you'll notice on like the first 3 problems, I wrote m is equal to y-intercept is equal to. M is equal to y-intercept is equal to. M is equal to y-intercept is equal to. And then I stopped. Why? Because I want you to stop? No, because I thought you would catch on. I thought you caught on by then, okay? All right, so we're going to make one big graph, and I'm going to graph 4 different things on this graph because I don't want to draw 4 graphs. Okay, so here's the first one that we're going to graph. The first thing, A, y is equal to 2x. So this is what I'm looking for, okay? Every time they tell me to graph something, I'm going to write the slope and the y-intercept because I think that helps kids not make mistakes. And I want to know, do you know what it is? All right? So what is my slope? 2. Is it 2x? No. If you put an x on it, I'm going to mark it wrong. Okay? The x changes. This slope is a constant. That means it's going up at a constant or down. This one's going up at a constant rate. Okay? If it changed, if you put an x on it and then you could change the slope, would that line be straight? No, it'd be kind of crooked, or it could be a curve or something like that. Okay? So it's just this number, the coefficient of x. What's my y-intercept?
0.
0. There's nothing out here. That's my 0. Which one do I graph first?
Your intercept.
Your y-intercept. So I go to 0 and I make a big fat dot. My slope is 2. Some kids don't like it to be an integer. They want it to be a fraction because it is rise over run. I'm always going to run to the right. Okay? I'll go up and to the right if my slope is positive, and I'll go down and to the right if my slope is negative. A common mistake for kids to make when your slope is negative is to go down and to the left. If you go down and to the left, what kind of slope will you create?
Positive.
A positive, because it'll be a negative over a negative. See, you went down for the negative, and then when you go left for a negative over a negative, you'll make a positive slope, okay? See, watch. If I start here and then I go down and to the left, then do you see the point will be over here, and that would make a positive slope, okay? So make sure if your slope is negative, you go down and always run to the right. So my slope is 2 over 1, so I'm going to go up 2 and over 1, up 2 and over 1. I'm going to make 3 big fat dots. It takes 2 points to determine any line, so I do 3 just to check myself and make a better line. Anybody got a question? Everybody okay? Yes? All right, here's yours. You do this one. Y is equal to x plus 3. Go. Tell me what the slope is. Tell me what your y-intercept is, and then graph it. You have less than a minute. Okay, you got it? Yes? Everybody okay? Tell me what you got for your slope. 1. Very good. The number in front of x, and it doesn't have to be written there, is a 1. What's my y-intercept? 3. So which one do I do first? So I'm going to go up to 3. 1, 2, 3. And then I'm going to use my slope, which is 1. If you want to, you can write it as a fraction, 1 over 1. So up 1 and over 1. Up 1 and over 1. Up 1 and over 1. And here is my line. If you accidentally miss a point, you just make a big fat point. And you can make it be on your line. Okay? Alright, is this hard?
No.
No? Alright, let's try another one. This one's going to mess a third of the class up. A third of the class is going to go, what? They're not going to know what to do. We talked about these before. I gave you an easy way to remember. Okay, you got it? All right, do you remember the easy way? Look at that Y right there. If you turn him upside down, what does he look like? An H. He is a horizontal line. Anytime you have a Y and you don't have any X's, he's a horizontal line. Just solve for the Y. Whoa, let's see. At -3, so I'll draw him right here. Sometimes it helps to draw him first. Okay, so there he is. What is my slope? 0. How many X's do you have? 0 X's. Okay, what's my y-intercept?
-3.
Perfect. Okay, next, last one, then we're going to move on. So this one, x is equal to 4. Graph it. Tell me what the slope is, and tell me what your y-intercept is. All right, what kind of line is this? He's a vertical line. Look, he's like 4 V's all stuck together, screaming, I'm a vertical line. So go to 4, 1, 2, 3, 4. Make you a vertical line. What's his slope? Undefined. Very good. What does that look like as a fraction?
X over 0.
Yeah, anything over 0. Okay, look at this line right here, y'all. You could say his rise was anything. It could be 4 or it could be 400. But what's his run?
0.
Nothing. So anything over 0 is an undefined slope. What about my y-intercept?
There is.
Very good. Since there's not one, can I put 0 here?
No.
Very good. So one class period they were like, there's not one, so it's 0. I'm like, whoa, wait, those are 2 totally different things. 0 says it intersects it right here, and I said if there's not one, then put none. Okay?
Can we just put NA?
Let's put not one, or I mean, yes, it is not applicable. You're right, but don't put empty set, okay? Because it's not. You're not looking for a solution set or anything like that. Okay? Sometimes kids want to write that. I'm like, that's not really fitting for that. Okay. So one last problem for the graphing, and then we're moving on. So graph, this is example 2. Graph y is equal to -2/3 x minus 1. Okay? Graph that. I'll give you a minute. Okay, you got it?
Easy now.
All right, so remember, every time we're gonna write down the slope and the y-intercept. Guys, listen, if you have a negative slope, you need to pay attention, okay? Because a negative slope is gonna, more kids will miss a negative slope than they will a positive, okay? So what's my slope? Negative 2/3. As soon as I see that negative, I go, oh, I gotta be really careful. I want to make sure that on a negative slope, my line goes where? Which way to the right? Down to the right, okay? You want to make it sure, I mean, I'm going to look at that slope and go, oh, he's supposed to be negative. When I get finished, is he going down to the right? What's your y-intercept? So I'm going to go to -1, make a big dot. I'm going to use my slope and go down 2 and over 3. Down 2 and over 3. And then I'm going to make my line. And he is going down to the right. Anybody got a question?
How would you read that in the infinities?
Okay, it's still gonna be the exact same thing, okay? Because he's going up and to the left, his domain, which is you're reading the x-axis, is still gonna be from negative infinity. He's going down to the right, so it's gonna go to positive infinity. All right? His range is still going down, so he's gonna be from negative infinity to positive infinity. Anytime you have a line, with the exception of a horizontal or vertical line, my domain is going to be negative infinity to positive, and my range will be the same. Okay? Now, what'll look different is for a horizontal line, my domain's from negative infinity to positive infinity, but my range is just whatever that value is. So my range in this case is just -3. The y's are always -3. What can x be? Any number in the world, y is -3. And this one's flipped, okay? My domain is only 4. My range is from negative infinity to positive infinity. Okay? So other than the horizontal and vertical line, the rest of them will all be negative infinity to positive infinity on all of them. Okay, so here's what we're going to talk about next. See if you can guess what this is.
A cloud. A dog.
A
Cat.
bird.
A mouse.
I'm gonna guess, no one's gonna guess it until I draw this one thing.
Right.
A lion.
Walrus.
There you go. He's a big giant walrus, okay? But we're just talking about baby walruses, okay? They're called a calf. So here, I'm gonna give you an equation. Y is equal to 5x plus 42. And I'm gonna tell you that this gives the length of a baby walrus in inches with respect to his age in months. Okay, so Y is his body length in inches. All right, and X is his age in months. All right, so look at that equation right there.
Yeah.
And tell me what you know about a baby walrus.
They're big.
They're big. I mean, like 1,000 feet big or what?
Good size.
How big?
Good size.
People, look at that equation right there and be specific and tell me what you know about a walrus calf.
At least 42 inches or bigger.
What is the 42?
They, like, their starting length.
Their starting length. Where do they start? It's like the post office deliver them and that's where they start?
When they come out their mama.
Okay, when they're born, a walrus calf is 42 inches long. That's about 3.5 feet. That's a pretty good sized baby. Okay? What does this number mean?
That's how much it grows.
Very
over
specific.
time.
Y'all listen to me. When I say tell me about a baby walrus, I want you have to use numbers and words. You can't just say, well, he grows really fast.
It grows 5 inches every month.
Very good. He grows 5 inches every month. Do you see how specific that was? How big is a walrus calf when he's born?
42.
42 inches. How much does he grow? 5 inches every month. That's what I want to know. When I ask you to explain what does this equation mean in terms of this problem, then that's what I want to know. Now, let's make sure we make this little side note. Does that mean that every walrus calf is 42 inches when he's born?
No.
No, that's the average, right? Are there gonna be some that are bigger and some that are smaller?
Yeah.
Yes, there are. Will there be some that don't grow as well, all right? And then some that grow faster, all right? So this is just an average, but that's it. All right, so let's graph this thing. Where's the graph gonna take place?
At positive 42. Like that's.
On a coordinate plane, where will the graph take place?
0, 42.
Quadrants?
First
Okay, first quadrant, all right? So here's the quadrants, in case you didn't know. There's quadrant 1. This is where most real life happens, right? Because you can't go back in time, okay? And obviously, you can't go back in length, negative lengths. I don't know what that looks like. All right, so this is quadrant 2, this is quadrant 3, and this is quadrant 4. Notice that the quadrants are in Roman numerals. If you use Arabic numerals, which are what we use, okay, I'll mark it wrong. Everybody got it? Sometimes kids want to know why it goes backwards. In pre-cal we talk about angles, okay? So if my angle starts here and I rotate the angle, I'm at 90 degrees. Do you agree?
Mm-hmm.
And now I'm at 180 degrees.
Mm-hmm.
And now I'm at 270, and then all the way around the circle is what? 360. So do you see how those correspond with the way my angle rotates? All right, so 1, 2, 3, and 4. Okay, so y'all said this will all take place in the first quadrant. Are you with me? What does the x-axis represent?
The age.
The age. In what?
Month.
Months. And that's important, right? Oh, not moths, but months. Okay? That's important, because if you didn't say that, I might think that was in years. Okay? So what does the y-axis represent?
Length or inches?
Body length. And it is body length, right? Because if you just said it's in inches, people might think that was their tusk length or something. Okay? All right. So at what point do we stop calling children by their months?
After 12.
1 year.
After 12 months.
2 years.
2 years.
2 years.
Yeah,
What?
2 years.
Yeah.
Like
You've heard
18
people
months
say,
old, so-
like my grandson is, 21 months old? 21 months old? Not 21 years. Oh, Lord. I would hopefully be at home by then, but anyway. He's 21 months old. The other one, Sophie, his sister, is 3 months older. All right? So, at 24 months, people start saying they're 2, 2.5, 3, stuff like that. But up until then, moms will say they're 18 months or 20 months or whatever.
But what if
Okay?
you don't know
So-
that terminology on the test?
I'm sorry, what?
What if you don't know that terminology on the test? Like, what if you
Oh, that's okay. That's okay. We're learning some stuff. It's all right. So I'm going to go from 0 to 24. Okay? Now, 0 to 24. Do I want to go by ones? No. What would be a reasonable thing to go by?
2.
5 doesn't
2,
go
4,
into
6.
24.
Okay.
You can go to 25
Yeah.
or
12.
Yeah, you could go to 25. Okay, but here's what I'm going to tell you what the rule is. This is my standard. Okay? My standard is to try to hit around 10 tick marks.
So 4.
Okay? It's 5 and up.
How about 3?
No,
3.
that'd be 5, 10, 15, 20, 25. You got 5 tick marks. I'm taking your points
How about
away.
3?
Okay? So I would say either go by 2s or 3s. 2 will give you 12 tick marks and 3s will give you 8 tick marks. Either way, you're right there around 10. Do you understand? Okay, I'm going to go by 2 just because more kids will count by 2 than they would by anything. But watch what I'm going to do to make my life a little easier. I'm going by 2, so I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Did I go by 2s?
Yeah.
Yes. I just didn't number everything, okay? But everybody can figure out what they are. Do you agree?
Mm-hmm.
Okay. Now, what about my y-axis? Do I need to start at 0?
Yes. Or 42.
I could start at 42. Okay, well, listen. He's growing pretty fast. Do you agree? He's growing 5 inches every month. He's growing almost a foot every couple of months. Okay? So, what should we go by?
Feet.
By what? No, we're going by
21.
inches. We're going by inches. Okay? What should we go by? Do you want to go by ones?
21? Go by 20, what?
21,
Listen,
22.
listen.
By 21.
Listen, do we want to go by ones?
No.
Do you want to go by twos?
No.
People, you're going to have to go to like 120 or something.
Let's go by
Okay?
tens.
Go by tens. Okay, what do you want your first one to be?
50.
40.
Yeah, 40. Why 40 and not 50?
Because you need 40. Because you need the
Because I need 42, and that's where I'm going to
Well, wait, I
start.
thought 0
Okay.
was 42.
Now listen to me. 0 can't be 42. 0 is 0. All right? Now listen. Y'all said go by tens. Can I do this? Can I go 40, 50, 60,
Yeah.
70, 80? I can do that? I thought that when I went from 0 to 40 and I said my first tick mark was 40, that says I'm going by what? 40s. And then all of a sudden I changed it to tens and I went by tens. What do I need to do?
3 tick marks.
3 tick.
Do the little squiggle doodle.
There you go. Make a little break in here. A little heartbeat. Okay? This break says, hey, there's part of this y-axis that's missing. All right? I'm just starting at 40 because it's a reasonable place to start. But I cut out a bunch of my y-axis. Now I can go by tens. 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. Okay? Now let's plot my graph. What's my y-intercept?
42.
What?
42.
42. So I'm going to make a big dot above, right above 40. Just right above 40. Okay? Because that other little tick mark is 50. All right. Now, how many points does it take to make a line?
2.
At least
2. We put 3 on our graph. Listen, we put 3 on our graph because 3 is a good check for yourself and it helps you make a better line. Okay? But really, you learned in geometry that through any 2 points, there is exactly 1 line. Okay? No more than 1, no less than 1. So I only need 1 more point. All right? Now, do I want to be counting slope here? People, you don't want to be counting slope when you change the scales. Okay? Well, this scale may not be so bad because my slope is 5 and I went by 10s and by 2s, and that divides out to be 5. You normally don't want to be counting slope. So, can I do this? Can I just pick a number over here and plug it in and see what it is and then draw my line?
Yeah.
Okay, so I would say stay away from this guy over here. The farther away that you get, the better your line is going to be. Okay, so I may not want to go out to 24, but what do y'all want to pick?
16.
16? Okay. So let's pick 16. What am I going to do with that 16?
Plug it in.
Plug it in. I'm going to plug it in that equation right here. 5 times 16 plus 42. What's 5 times 16?
80.
90?
Sorry, what?
9.
Is it 90 or is it 80? It's 80, isn't it?
Yeah, it's 80.
80 plus 42 is what?
122.
Yeah, it's 122.
Yeah.
Okay, so at 16, I should go up to 100, here's 120. Okay, so 122 is going to be just a tad bit above him. So somewhere around there. Do you agree?
Yeah.
And there's my line.
Do you want us to put in parentheses next to it? 80, then 120, or
No,
16?
you can only write that if you want to. I'm okay with that.
If we just.
Okay? All right. So let me ask you this. Let's talk about this guy's domain. Let's talk about his domain. Now, is this not a line right here?
It's a lot.
Is this a line? What did we say the domain for all these lines was?
Positive infinity.
Negative infinity to positive infinity. What about this one right here?
It'd be 42 to positive infinity.
Domain.
Oh.
Does he go from negative infinity to positive infinity?
No. Starts off positive, doesn't
Implied.
This has what's called an implied domain. What does the word implied mean?
It's a thought of, understood.
It's understood, okay? It means that it's understood. Is it stated? No, it's implied, okay? So here's my implied domain. Where does this guy, this little walrus cap, y'all know what a walrus looks like, right?
Yeah.
Big giant body with little flipper legs and a little flipper right here, okay? So where does he start out?
42.
At 42. He doesn't go to negative infinity. Like, what does that look like? Tell me what a walrus looks like that's negative 42 inches in length.
it? A couple cells.
Naked.
Like, I don't
No,
know.
it would still have link if it's
He'd
just
be
a couple
blown up or
cells.
something. All right.
But it's not
so,
inches, so it'd be negative.
42. Shh. Do you agree?
Yep.
42. Does he go to positive infinity?
No.
Does he keep growing every month? Or at some point does he go, I think I've reached my limit?
He thinks he reaches his limit.
I think he reaches his limit. He doesn't grow for forever. Do you keep growing forever?
No.
No. Do you start off and you grow at kind of a constant rate?
No.
And then as you get older, what happens?
You
It
stop.
slows down a little bit, and then eventually what? It just
stops.
levels off and it stops. And then really what happens to you?
Shrink.
Yeah, you
Die.
start to shrink. Okay? You start to get shorter. All right? So 42. We don't know what it goes to. All right? But you could look it up, right? You could say, what's the average length of an adult walrus? Would it be different for a male and a female?
Yeah.
Oh, most definitely. The males are the big guys with the big giant teeth that fought off other guys that weren't their
like,
girls,
would
right?
we put question marks as the answer?
Well, I mean, they didn't really ask me about the domain. I just was talking about this, implied domain.
Well, I mean, a
What
question
kind
mark.
of questions, what kind of problems are gonna have an implied domain?
Ones that you know the answer to the other
Real
side.
life.
Real life problems, that's exactly right. Real life problems will have an implied domain, okay? So, like if I were talking about the circumference of a circle, C equals pi times D. Who's my domain, C or D? Shame, shame. What's my domain, people?
D.
D is my domain. Not because it starts with a D, all right? But because this is my independent variable and this is my dependent variable. Okay? So what would be the implied domain here?
Pi. C. Domain.
What does this guy talk? What does this stand for?
Diameter.
Diameter of a circle. The diameter of a circle is not going to be what?
0 or negative.
0 or negative. What kind of circle has a diameter of 0?
No.
That's
A
not a
non-existent
circle.
circle.
That's just a point. All right, write this down before you put your stuff up. We'll talk about it tomorrow. Standard form.
If you asked us for a domain, would you give us the answer to the other side? Like,
Yeah,
okay.
yeah.
I'm just making sure.
I wouldn't make you know about. This is standard form. AX plus BY equals C. Okay, and here's the rules on this standard form. The X's and Y's have to be on the left. The constant or the plane number is on the right. And one more rule. A, B, and C must be integers. What does that mean? Integers.
numbers.
No what?
No decimal.
No fractions and no decimals. Okay, so we'll finish this and then talk about one more thing tomorrow, and then I'll let you have the rest of the time to review for the test.